Surrounded by some of the bony orbit, bones around this region, that please feed my zebra, bones around the eye. And what we're able to see here, well, just starting out, we learned the muscles earlier on, the rectus muscles, the oblique muscles that rotate the eye. And right here, this is where we're able to see now that lacrimal gland, or like this model here, they're both right sides. So the lacrimal gland that's creating the tears. And this is the correct model. You see how it's not connected onto the eye, but around the orbit of the eye, the lacrimal gland. But still on that superior lateral side as we described. And what we have here, the part that fell off would be the cornea, the clear part. So any problems or shape, the development of the cornea is the reason why we need glasses.
Why does, I had surgery done a year ago, why does thinning out the cornea help your vision?
Oh, well, light rays come in, and as they come in, they're now bent in, they're refracted, they're bent in, so that they focus right on the retina. So they're just reshaping it, or actually, thinning it out, so it correctly is in focus on the retina.
Can I shave too much of it all?
Well, in theory, any error in that procedure could be fixed again.
Can be?
Yes.
Oh.
In theory.
Mm-hmm. And here, the white part, there's the sclera of the eye. And just as we open it up. Okay, so this is all the fibrous tunic, just these two portions, the cornea, sclera. So now, deeper in, we're at the area of the vascular tunic, and we're able to see now the iris. So this is one with blue eyes there, the iris. And another portion of it here, where we see the blood vessels drawn in, that's called the choroid. And I think on this side, if we open it up, there went the cornea and iris. And the choroid, you can start to see the blood vessels, the red and blue in this region, choroid region. So we could open this up a little more. And we'll turn it around this way. So now we're able to see the lens on the eye, or on this piece, the lens is glued in here. And with the lens dropped in place, you can see those yellow suspensory ligaments wrapped around it, and then surrounding that entire area, the ciliary body. So how it's a full circle, the ciliary body, suspensory ligaments all around the lens. So there's a ciliary body all around here, the yellow lines, the suspensory ligaments, and those all connect to the lens of the eye. And on this model, we just see a lens, and in black, we have the ciliary body, and just putting it in place, you can see once again that ciliary body is a full circle around the lens, and it doesn't show the suspensory ligaments. And why are they called ligaments if they connect to muscle? I don't know. So moving further inside, so you notice this piece comes out of the eye, or on this area, this whole circular portion comes out of the eye. So this is just representing space, the posterior cavity, all of this space here. And inside, the fluid inside of here would be that vitreous humor. And we don't have any eyes to dissect here. That's too bad. But if you were to dissect the eye, I mean, it's really just this clear gelatinous mass that's inside. And this just helps to hold the retina in place. So the internal surface, the very orange inside, that's the retina, the nervous tunic. Out here is the vascular tunic. And all of this sat inside of the fibrous tunic. So there's three layers to the organ. Sclera's fibrous tunic, the choroid's vascular, and now the inside, the nervous tunic we have here. And we should be able to see, two spots on here. So if we look at this area, you notice the nerves and the blood vessels enter the eye, and you turn it around, it's this white spot. That's the optic disc. So that's the location in each eye where we don't have photoreceptors. That's a point in each eye where we can't detect light, we can't see. So that means every time you're looking at something, like in your field of vision, there are two gaps, and your brain quickly has to interpret what's in that gap in your field of vision. And you notice another small spot here. It's a very tiny yellow spot here. You should see the same thing over here, this small yellow spot. And if you notice on this model, if you look straight through the eye, it goes to that yellow spot there. That's called the fovea. And that's the location of your best vision. If you want to really look at something, you stare straight at it, and that light goes in your eye right onto the fovea. So it should be, here it's not shown correctly, it should be a little indentation. That depression's the fovea, and that's the spot of our best vision. Or here it's just a yellow spot. So we have two areas on the nervous tunic where the nerve enters, that's the optic disc. And this model doesn't show that, but it would be right in here where the optic disc is, the nerve comes in. And very close to it, little depression, the fovea. So a lot of these models are shown with their answer key attached to it. So you'll be able to see, of course, all of these structures. And we'll just put it back together. The space of the posterior cavity, we see the lens here. And we have the clear cornea, the blue iris. And we can close this one up. And once again, that space of the posterior cavity, all in the posterior part of the eye. We have that ciliary body, suspensory ligaments, with all connected to the lens here. Putting this together.